My name is Katie Roberts. I'm a technical director at Nearform. I'm also an AI native engineering specialist, and I've been a TD with Nearform for nearly 6 years now. I've been an engineer for over 20 years, and I've been working with new and old code bases during that time, working on systems that scale and need to be reliable. And today I'm going to talk to you about how you can stop maintaining and start evolving and applying AI native engineering on brownfield code bases. This is my slide about Nearform, who we are. We are a client consultant services organisation, as DC's just said much more eloquently than me. We've got 13 years experience. We've got over 500 Nearformers now. We're across 20 different countries. One of the interesting things about Nearform is as well, we only ever hire at senior and above in terms of our engineering staff, which does make us a little bit unique in that sort of consultancy space, because we bring in teams who really do know what they're doing. So AI native engineering works. And how do I know this? I know because I've seen the numbers. On Greenfield code bases, AI native engineering is an absolute match made in heaven. We can do things right from the start and keep everything neat, tidy, from the design, product and architectural decisions in the spec. We can use those as the basis for the build. We can make sure that the design input is there right from the beginning. We can define what our systems do, what the agents handle, and most of the implementation. And this means that our product managers are getting a much more input in the development process, getting their prototypes earlier, making sure that they're seeing what they need earlier. UX get feedback earlier on what the users think. They've got working prototypes quickly, within weeks, not months. And development teams can move much, much faster because they're building the great stuff in from the start as well. We're thinking testing, observability, security, all the good stuff right from the beginning. And a lot of the talks that I see talk about this. They talk about these stats, these great things, all of these great things. And a lot of the metrics that are reported in the press seem to be based on these types of builds. And we have seen this in Nearform as well. So look at that. 80% better, faster kickoff from zero to running app in days rather than weeks, and sprint zero virtually eliminated. 4 times development velocity. Fantastic. Who doesn't want that? Consistently reported across a farmer analytics and fintech data platform where they were using spec-driven development. 50% faster to MVP, clickable prototypes in days, not weeks, and the time to MVP half, with all that quality stuff baked in from the start. And this is great. It's brilliant that we're getting this, but not everybody gets to work in the Greenfield. An estimated 60 to 70% of all enterprise software is brownfield. It's legacy. It's there, and it's been doing a great job for 5, 10, 15 years. And this means that there's a huge, huge amount of software out there in the brownfield space. With that comes a whole load of problems that if anyone's looking after a brownfield code base here will probably be aware of. Accumulated technical debt. Any project that's over 3 months old is accumulating technical debt. I don't care what anyone says. You cannot keep it clean forever. Test poverty. Oh, so many builds that I worked on where the tests have been allowed to rot because there was a problem with the running it on the CI, or during the development phase, there just wasn't time to get the tests in place. So it's one of the things that got cut. Nobody means to do that, but it happens. Tribal knowledge. Critical knowledge of a system lives in 1 or 2 people's heads, and they are just about to retire soon. That's always a fun one. Interdependent systems. Everything appears to be coupled to everything else, and there's no clear architecture. Dependency rot. I was chatting to you earlier about this. People running systems that there are old dependencies and they just can't be migrated up. And you know that it's going to take an awful lot of time to migrate from, I don't know, let's say node 12 to node 24 where we are now. That happens. Invisible contracts. Implicit behavior between callers that are things are dependent on, but they're not documented. And fear-driven development. So there are areas of the code base that are so fragile now that nobody wants to touch them. And most importantly of all, this thing must stay live. Every change that happens while the system is production, there is no maintenance window, there is no downtime, and you cannot risk the users you've got, because these sorts of systems are serving hundreds and thousands of users, depending on who you are. And this is nobody's fault. Nobody chooses for their systems to get like this. This is just what happens over time. And people call it the ball of mud architecture pattern. Whereas I like to think of it more like a city. Cities are successful and they evolve over time. And brownfield systems work. In most cases, they work incredibly well. They've been around for that period of time whilst maintaining the complexity of the demanding code base. And they've been managing the problems of performance, security, and scaling that come with that. The city has evolved over time and it's adapted to people's needs, just like your code base has. And if we think of it like, if you think of code base like a functioning city, like say where we are now, this is a lovely picture of London. And you can see here that there are well-maintained places. There are definitely easy to go down highways that you can see the way through. There are maybe some less well-maintained places. There are definitely some dead ends. And there are probably places that you wouldn't want to go alone at night. And so how do you evolve your code base that maybe has this same sort of structure into something that is not, how do you build on something this complex? So I've got 3 different methodologies. You need a map and you need to know how you're going to get to where you're going. And how you're going to get to where you're going kind of depends on the problem that you have. So let's start with solving the way we want to travel. Pseudo Greenfield development. This is great when you've got to build a feature quite quickly. So you've got a very, very frustrated product owner. You've not been able to put out features for a long time. And your legacy code base is fragile internally. But what you can do is you can branch out and almost treat it like a pseudo Greenfield phase. This gives you find a feature that you can work on, something that is isolated enough. Maybe it's new, maybe it's adding a new piece of functionality, a new set of screens, a new set of, I've got lots of examples at the minute, but find that and build it in isolation from the wider code base. You can then build that replacement using spec-driven development patterns. So you can move quite quickly with this. And then you can then build it back in and integrate with existing code from APIs and existing libraries. Now, the first part of this moves very quickly. The second part of it, where you're integrating with the backends, tends to move a bit slower, but you do get results really quickly. And that gives you some credibility with your product owners, but it also helps to just manage the next stage of development. And it can also be a precursor for Strangler fig as well, which I'm going to talk about in a second. So the advantages are that you can move faster until you've got to integrate that branch back in. Disadvantages can be that you can end up with developers' tourist problems. So you've got a bunch of developers who are able to build this feature branch incredibly well, but if you ask them to work on any other part of the code base, they just don't have the context or the understanding of what they're going to be doing. There's a duplication of shared concerns. So if you're having to build in things like auth, logging, error handling, all of these things might exist very well in the legacy systems. But in your pseudo Greenfield branch, you might be solving the same problem again with slightly diverging approaches. The longer this runs as well in isolation, the pseudo Greenfield branch, it can start as moving further and further away from, the more divergent it becomes, the more expensive it comes to reintegrate it. And without discipline, it stops being from being a temporary isolation and becomes a permanent flaw. And testing this path can sometimes be difficult because as soon as you get to that integration point, that's when you have to do all the testing at that point, because that's where your product lies. Then there's the Strangler fig pattern. This is a great pattern. Strangler fig is, the pattern is where you take responsibility from your old code one slice at a time. It's named after the Strangler fig tree. So the Strangler fig is a fig that it drops a seed and then it starts growing vines down, and then slowly it strangles the tree away. So the old tree it dies inside, but the new tree, the vine becomes a tree that takes its place. So it takes responsibility from the old legacy work one slice at a time. And what you can do is build an interface for the code that you're wanting to strangle away, replace that code, and then effectively switch your traffic from that code to another. It's great when you need to, when you're thinking about replacing your entire system. It's a pattern that's been used at places like Uber and Netflix, and another BBC as well when they were moving to microservices. It was a way to take away the old legacy and then move to the new. You can keep going with no downtime. Their legacy system can be poorly understood, but you're intercepting at the edge. You can see what it needs to do, so you can develop what it needs to work on. Advantages are that the new code is effectively Greenfield, but it's based on the legacy functionality, so that allows you to do that. Replicating what's needed and leaving behind the bad patterns, that's great, effectively Greenfield work. No need to touch the legacy codebase at all. You've got a facade that's intercepting at the boundary, keeping the old system frozen. No downtime. You can do this almost with zero downtime. Routing layer provides a natural place for doing things like feature flags and A/B testing, canary traffic, rollbacks, and progress is visible. You can see the percentage of traffic starting to hit the new areas of code, and as the struggling is happening over time, you can see the old stuff just withering away. The disadvantages are that it does require a routing layer or a facade for a backend system boundary. It's non-trivial in terms of infrastructure costs. Data synchronization between the old and the new system can be complex. Legacy systems must be kept running and consistent until you've fully switched over. So that can be expensive as well. And parcel strategies can end up living for a long time. So for years, if they're not, and it can take years if it's not really committed to that this is something you're going to do. Final one I've got is branch by extraction within the application. So whereas the Strangler fig is quite big, and it's quite a big architectural change, this might be something where you go, I know I'm already working within this application. I need to surgically, I think last time I said this, I said, remove the kidney and replace it with another one, which is still a fairly gross metaphor, but it does work, and so I'm going to stick with it. But it's a very surgical approach. You need to understand where you're going to be working. You create an abstraction layer at that point, and then you start working within the code to create the new patterns, the new implementation. And then at one point, you can switch from the current code to the new implementation. It keeps track. So the advantages are it keeps the trunk releasable at all times, because you are releasing both pieces and you're using feature flags to flag out the other work. Both implementations can be active at once. You can compare behavior. So production testing's reasonably easy compared to some of the others. And the natural surfaces are hidden, dependencies and coupling. The informal refactors maybe wouldn't over time. Disadvantages is the abstraction itself is extra code to maintain, and eventually you have to delete the old code. You've got to remember to do that, otherwise your code's just accruing yet more technical debt. And it's temporarily a liability. If teams lose motivation to continue with the new implementation, you can end up with a half-finished migration that then keeps going long after it's marked as when it should be done date. And identifying calls across the site on a large brownfield code base can be tedious and take some time to do, and it's easy to get wrong. But branch by abstraction is a useful one if you are already working in there and you want to try and improve your code base as you're going. So I'm using AI to apply these methodologies. So this is where it starts getting interesting. This is AI will confidently hallucinate about your code base. If you point to your AI, your code base and say, I'd like to refactor this, without really scoping down what you're doing and not thinking about what direction you want to go, it will give you some great ideas, and it will, like I say, very confidently hallucinate about your code. I tried this once, and I wasn't actually going to push anything to production, but it was amazing to see what Claude would do if I just let it go at it. Autonomous coding agents are deployed and established on brownfield codebases. Without strict guardrails, they will rarely go rogue in a malicious way, but they are very overeager. They typically cause havoc through over-optimization, generating dark code that passes all the tests, but undermines the actual architectural constraints and creates hidden technical debt. But it's 2026, and we shouldn't need to remind people of this, should we? But we do. It's still high. And these sorts of things, you see these things from time to time. I mean, this was a very quick search I did, and I was finding them right up till March. Letting the agent loose without bounded scope produces refactors that aren't tested, aren't grounded, and will not necessarily do what you wanted them to do. So, what you do instead, you start by gathering the evidence. You need to map out what's there. So listen to what problems your development team are having. Understand what they're facing. Anyone who's worked on the code base, even for a short period of time, will have a view on what's working and what's not, what's wrong and what can be improved. And what you're trying to do here is build up a map of evidence of where you are. So Adam Thornhill wrote a great book called Your Code as a Crime Scene. And in that, he talks about using forensic psychology and how you can apply the same patterns for when you're looking at your code base. And if you think about your developers are the eyewitnesses to the problems that you're seeing, they're seeing it all the time and they know what they're doing. So when I've done this, we've done it as like a Miro exercise, or you could do it as a whiteboard exercise. Everybody has an opinion. Everybody knows what needs to fix in this thing. And then you can start mapping out what's wrong with the code that you're working with. And doing those sorts of sessions, you get a good knowledge mapping. You're not going to be able to fix all the problems, but you will be able to fix some of them. From this, you can then use your AI to do the exhaustive work of mapping out the code base a piece at a time. So looking at it by slices and thin slice down. This is a piece of work that I want to understand where these data calls are going to. I want to understand what the networking view of this looks like. I want to get a map of how this looks. I want to know what this code base is doing now, not what the documentation that was written 5 years ago is telling me it's doing. Because things evolve over time, and I'm very sorry to say that developers don't always update documentation as they go. It's just, again, one of those things. Nobody means to do that, but it is not always the highest priority. Some things you can do with AI, we've used it to identify coverage gaps, to identify smells within the code base, not to actually go in and try and fix them, but to identify the areas. To identify areas, it's been really, really great for identifying duplicated code. So repeated areas of where it's doing effectively the same thing, and then you get a picture of why is that code mirroring that code? What is it that they're doing? What are the similarities? What are the differences? Can we start using an inheritance pattern rather than trying to maintain two branches of the code? And using AI to do this is significantly faster, but it still needs humans to review it. So it needs, and that human, as Ning was saying earlier, needs to be somebody who's experienced and knows and understands and can spot a bad coding pattern that is coming out as well. So you have to do this. These are, and document as you're going, but these are, you start getting a map of what's good and what's bad, and then that can help and drive what improvements you can then make. And it also, something that I found by doing this is that you're getting very objective data. So I might write something using AI, and then I can put it out to my team to review, because I have a team of very senior people. I want them to be able to review what's going on. And they will come back and say, well, that's one way of approaching it, but this is another. And I've found that because we are not, oh, this is the this is the most principal engineer in the room. I must follow whatever they say. You're getting a much better sort of interaction between the team. We're getting a much better diversity of thoughts as a result of that, which means we're getting much better outcomes when we're actually working towards. And now you've got the destination, you've mapped your destination, you can start moving towards where you want to go. So my core principles for AI-assisted brownfield development: don't trust the AI output blindly. Work in small scopes. Version control everything. Version control is awesome. Always version control everything. Create a findings backlog, and you need to be looking at that in terms of prioritization where you want to work. Make sure your docs are human readable. They need to be reviewed and understood by the team, not just stored. And put guardrails in place. The more tests you can put in, the more logs you can put in, the more static code analysis you can put in to catch your AI regressions. So before we started any work within the particular brownfield project I'm going to talk about, we made sure that the Sonar Cube stuff was working well, and we trusted what it was coming out with. And it's really helped with what we're doing. You check on my notes to make sure I've not learned anything. Yeah. And it helps because we focused on one area at a time. And one of the things with that is we used feature development and feature requirements to help drive that, as well as knowing where the technical backlog problems were. And some examples, let me actually give you some solid examples. For a pseudo Greenfield approach, this was a piece of work we did for, it's a type of recruitment platform that we were working with. And the CPO there said, we've managed to ship in 8 weeks, 6 months or so. We used the spec-driven development approach. We looked, there was a lot of legacy documentation with this particular one. A huge amount of product requirements had been written over the years. So we used AI for that to go through it, understand, and then synthesize down so that that could then be taken to the new product team and then validated against what was needed now. There was some the reverse engineering of requirements, that is. The detailed codebase mapping, they used AI to reverse engineer the documentation from the existing codebase, creating that AI context that should have taken weeks. It took hours. And then from that, they used the automated story mapping. So PRD creation, Jira story mapping in this particular case, and design alignment. So we really did see a huge amount of speed, time saved, and just it allowed the team to reduce the context of the stuff they were working with. Branch by abstraction. I've got a good example of this one. We identified a problem that needed to address. It'd been tried to be addressed before. It had been given up on because it just took too long. It just wasn't valuable enough to put the time in. And this particular code base, it's over 500,000 lines of code. It's a tightly coupled distributed monolith. It's a 6-year-old code base. It's very successful. You can't have downtime on it. And the individual implementation that we needed to do, one time we had to upgrade one of our libraries, AG Grid, for the latest features. And when we tried to do that, it took months. It took months to do, because what we then discovered was that the grids in this code base that we'd inherited had been implemented individually without an inheritance pattern or shared abstractions. So you effectively had to go through them one at a time, check them one at a time, and code them one at a time, which then was making a huge amount of problems. And there was very little tribal knowledge with this project because the original development team had moved on. There was no document decision-making. There was no automated tests. And features still needed to be developed in parallel. Nobody was going to give us time to just do this. So what did we do? We identified all the components that needed to be migrated, and the developer and agent defined a good path. So they made a structured roadmap, and this became the documented spec, which we then formed a plan skill from. With all the technical and product considerations captured, along with things like observability, making sure that we were pushing in analytics as we were going as well, making sure that things were thoroughly tested as we're doing. And then we broke out work by component into Jira tickets. Now, the reason we still use Jira on this is because we have a product team who want to be able to see what's happening. We also have a manual QA team who actually need to see that as well. We've not managed to automate them away, and they do a fantastic job. So one battle at a time. And then we handed all of that to a development skill that we then passed through. So this is what our development skill looks at. It analyzes the requirements for each of the individual grids. It does a dedupe check, make sure that we're not doing the same thing again. It makes a test-driven harness. So, and these things can be run in parallel as well. So it's not doing it sequentially. There's an orchestrator which sits above, and then it manages the various different areas. And then it goes through. Having done those first three in parallel, it then gets to right, what do I have to actually implement? And it works through that with a predefined stack, making sure it's following the architectural rules. Then it does the static analysis code gate, quality gate, making sure that we're doing everything we can before we put it into human review state to ensure that it's meeting the standards that we need it to. Then we have a peer review on it, and then it's pushed. So the human who is driving it will take a look at the code, but it will still have another developer review it. That is a bit of a bottleneck, but when you're working in brownfield, you want a little bit of confidence in what you're doing, especially because you are going to, again, like I say, be managing and maintaining something that is currently live. You don't want to break it. And this is just giving us that extra layer of security. I do know we could probably put in more agents around the code review, but this is good enough for what we're doing. And then every time it runs through, it checks itself, and then it updates the master skill. If there is an improvement that it sees that it can improve on, it also, as part of that PR, will add improvements to the skills so that we can continue to make those substantial changes as we're going. And what we're seeing with that is we've been able to the first time we tried this, and the team tried to work through this implementation of an inheritance pattern, it took far too long, and it got abandoned because of that. That far too long was around a month for doing one grid, and if you've got 80 to go, you know that's never going to get buy-in. Now we've got the agentic flow. It takes one developer they can get through around 3 migrations a week, which is much, much faster. It's not fast enough yet, but as we are going through, we're seeing this is improving over time, because every time you run the agent, the improvements going in, and we're developing more and more of the standard components that can be reused. So you have a massive flywheel and velocity improvements, which is great. And we get a lot more buy-in since we've been doing this from our product team, for doing more planning, because we can then get these sorts of things done. So practical takeaways. Every code base has sieves. Find one and start there. And stop using AI to add to your technical debt. Use it to try and help pay it down. Okay. I think that's everything I have to say.